Hello everyone. In today's session, we are going to be doing the chain rule. As usual, we will first look at the topics we have covered so far and what are we going to be covering in this video. So in our previous lectures, we have talked about finding the derivative of a function using different rules. The constant rule, the power rule, constant multiple rules, sum and difference, and product and quotient rules. We also learned to find the derivative of trigonometric and higher order functions. In this lecture, we're going to look at the derivative of a composite function using the chain rule. Also, we'll be looking at finding the derivative of a function using a general power rule, and then we will apply to find the derivatives of trigonometric functions, specifically with the chain rules. So let's start with a chain rule. As said earlier, that we're going to be looking at differentiating functions, which are composite functions. And the composite functions are given in the form of y equals f circle g, and applying it on the independent variable x, or we write it as f of g of x. So let's look at an example. How would we like to differentiate these functions? Suppose we like to find the derivative of a composition of two or more functions, and we're going to take a very simple cubic function, x squared plus 1 to the power 3. So very simple and a natural way we might result, oh, let's take the derivative. That means, it's like the function x to the power n. So you take the power in the front and, subtract it from -1. So that's a very naive and a very natural attempt to do it. So if you take the derivative, what you get is 3 times x squared plus 1, the whole expression to square. So when we open it up, we're getting the derivative of this function, y equals x squared plus 1 cubed, to be 3x to the 4 plus 6x squared plus 3. It's a very naive attempt. So the question is this correct? It completely looks very natural, but is this question completely correct? Now what we're going to do is we're going to rewrite this cubic function, okay? And then we take the derivative of that cubic function here. So let's do that in the next slide. So here is the cubic, we apply the cubic function, formula on it, x squared plus 1 cube. So if you have not remembering it, you can write this as, say, a plus b, the whole cube. If you remember, it is a cube plus 3ab square plus 3a square b plus b cube. So that's the formula. Now let's look at what is our a. Our a over here in this expression, a is x squared and our b is 1. So substituting those values, so we get x squared cubed plus 3x squared times 1 square plus 3x squared the whole square times 1 plus 1 cube. So just simply doing algebra, we get x. Now this is exponential law, so 2, 2, 3, so x 6. Basically x squared cube means you're multiplying x squared 3 times. So it is x to the power 6 plus 3x squared plus 3x4 plus 1. So this is our y value. So if we take the differential of this, what do we get? Y prime is 6x5 plus 6x plus 12x cubed. Okay, this we know is definitely correct because what we did was we opened up this cubic function here and then we did the derivative. Whereas in the previous one, notice this is y prime, 3x4 plus 6x squared plus 3. Now this equation 1 and what we have got by applying the cubic formula is not the same. So that means our naive attempt is not the right attempt. That's simply natural way of looking at another way of looking at it. So let's now look at the right definition of a chain rule. Okay. Now, if y is a function of u, it's a differentiable function, and u is further a differentiable function of x, where u is given by g of x and y is given as f of u. Then y composite with g of x, which is given as f of g of x, is a differentiable function of x. And how do we write dy by dx? Remember, when we're differentiating with respect to x. So first of all, notice y is a function of u. So first you're going to differentiate y with respect to u times, you will then differentiate u with respect to x. Or in other words, the differential, so if this y is written as f of g of x, what does that mean? You're taking the f derivative of the function which has been evaluated at g of x times the derivative of g of x. That's what a chain rule of a function of a function. Now we can think of this chain rule in another form too. Okay, so let's look at that. Now we can think of this as composite function as having, so remember y equals f composed with g, or f of g of x. It is having two parts. One is the inner part, the other is the outer part. So what is the outer part in this expression f of g of x? F is the outer part, whereas g of x is the inner part. Now remember, we also said, hey, u is g of x. So this function y, notice, becomes what? F of u. Now, so when we're taking the derivative of this function y, it is the derivative of the outer function. Now remember, when we did the f in the previous slide, we said y prime is what? F prime evaluated at g of x times g prime of x. That's how we define the function. But if you write it in terms of the inner and the outer, so simply this means that the derivative of y is the derivative of the outer function at the inner function u, or you can replace g of x by u here. You can write this as f prime of u times u prime, because your u is g of x, times the derivative of the inner function. The same expression, but just said in some things which if you are more visual, you can say, oh, this is the outer function, this is the inner function, and the derivative of a composite function is basically derivative of the outer evaluated at the inner function times the derivative of the inner function. So what we're going to do is we're going to do a little practice of decomposition of these composite functions. That's what the next slide talks about. So here's the function f of g of x. The first function is x squared plus 1 cubed. Now remember, this is exactly what we started the whole section on chain rule with. So what is the inner function? Inner function is this, x squared plus 1. This is inner. Outside is the cubic function. So outer function is u cubed. Okay, u is a squaring function, x squared plus 1, whereas the outer function is a u cubed. Let's look at another example. Y equals 1 over x plus 1. Now, notice this is a rational function where your inner function is x plus 1, which is a linear function, whereas the outer function is 1 over u. That's the, it's your rational function. Now let's look at another trig functions here. Y equals sine square of x. Now notice this can be written as sine x the whole square. Sine square x basically means you're multiplying sine x twice. So you can write this as sine x the whole square. So notice the inner function is now sine x, which is u. The outside function is a squaring function given by u square. Okay, let's look at number 4. Now number 4 is a square root of another squaring function given by 3x squared minus x plus 1. So clearly the inner function is the function given by 3x squared minus x plus 1, that is u here. The outer is the square root, that's square root of u. Now let's look at number 5. 5 is another trigonometric function, but this is in a different form. It's sine of 7 of x. Now remember, 7 of x, guys, is an argument to the function. It's not sine times 7x. No, please, it's very important. It's sine of a 7x, which is an argument to the function. So the inner function is now 7x, which is u. The outer function is the sine function, which is sine of u. So what we're going to do is, I'm going to use these 5 examples, and I'm going to do most of these examples. I'll show you how to apply the chain rule, find the derivatives of these functions. We're going to go by the method of the inner and the outer functions. So keep one thing in mind. If you're using the inner outer, so remember one thing here. If your function y is f of u, where u is a function of x. So when I take the derivative y prime, this derivative, keep in mind, is with respect to x. So that means derivative of y prime is what? F prime of u times u prime. That's what is it. So in other words, we need to know what is the inner function and the outer function. And initially, I would recommend you guys to write the inner and the outer. And once you become comfortable with just looking and, oh, this is the inner, the outer, you can, skip these steps. But initially, it is very important that you go by the inner and the outer. Okay, now we already know the answer for this y equals x squared plus 1 the whole cube in terms of derivatives. That was done by applying the cubic formula. This time, we're going to apply the chain rule. Okay, so our inner function is u equals x squared plus 1. The outer function is a cubic. So let's try the formula. Y prime is what? F prime of u times u prime. So what is f prime of u? U cube, that's here, the whole taking the derivation, times u. Now remember, u is x squared plus 1. You take the derivative of that. So when you take the derivative of u cube, what is it? 3u squared times 2x. Now remember, you made the substitution of u to be, that is the inner function, to be x squared plus 1. So substitute the x squared plus 1 in place of u, because your final answer should always be in terms of u, sorry. So it is 3 times x squared plus 1 the whole square times 2x. Now let's apply the squaring formula. Remember, a plus b the whole square. I hope, guys, you remember, which is what? A squared plus 2ab plus b squared. So what do we get? 3 times x4 plus 2x squared plus 1 times 2x. And then you just open this up. You get 6x5 plus 12x cubed plus 6x. That's exactly what we got earlier. So let's see this one here. That's what we had. So this was by opening up this whole x squared plus 1 to the power 3. That is applying the cubic formula and then taking the derivative. The other one was simply applying the chain rule formula. Okay. Now, this is a very, very powerful rule for us, which is the general power rule. What it simply says is that if you have a function raised to power something, and the inside function here is u of x is a differentiable function of u, and your n is a rational number, then if I take the derivative of y with respect to x, then basically you're applying the normal differential on u to the power n, which is n times ux n minus 1. Now this, remember, u is a function of x and it's a differentiable function. You have to multiply by du by dx. So du ddx of un is n times u n minus 1 times u prime, where u is further a function of x. So notice your general power rule is a special case of a chain rule. Now once again, we're going to go back to the same problem we started this session with, and that is the cubic formula given by y equals x squared plus 1 the whole cube. So we're going to apply, now notice this is a general, you can clearly apply general rule because this function is your function of x to the power 3. So by the general power rule, what's the derivative of this function where y equals u to the power n? That means it will be n times u to the power n minus 1 times u prime. So let's do that. So u, remember, is x squared plus 1. So it's 3 times x squared plus 1 the whole square times x squared plus 1. You take the derivative of this function. And what do you get? When you open it up, you get 3. You're just applying the squaring formula, x4 plus 2x squared plus 1 times 2x from here. And then just do the simple math here. What you get is 6x5 plus 12x cubed plus 6x. Okay, let's go ahead and do some more practice of these problems. Okay, now let's look at the problem. Y equals negative 3x, negative 2x squared plus 7, this whole expression to the power 4. Now, as problems get messier, we do not want to open up this whole expression to the power 4 and then do it. So these kind of things, that's why the general power rule is very, very helpful. Clearly, this is an expression to the power 4. So your n is 4, use minus 3x minus 2x squared plus 7. So applying the general power rule is un to the power, you're taking the derivative of u to the power n, which is n times u, n minus 1 times u prime. So your n, remember, is 4. So 4 comes in the front, the expression given of u to the power n minus 1, which is 3. And then you take the derivative of the expression given by u, which is negative 3x, negative 2x squared plus 7. And when you apply, do the derivatives here, and so it's 4 times negative 3x, negative 2x squared plus 7, the whole cube, times the derivative of this expression, negative 3x minus 2x squared plus 7 gets negative 3, negative 4x. And then, if you just want to make it much more nicer looking, you take the 4 and multiply with the elements of negative 3, negative 4x. And here is your answer. Okay, let's pick up another example. Now, this is an example which we talked about when we were decomposing composite functions. And I said that we will do some of these problems. So let's pick up this problem given by y equals square root of 3x squared minus x plus 1. If you have forgotten, let me show you. This was what we talked about, decomposition of composite functions. So we're going to do this problem. We're going to take the derivative of this function. Okay, and this function, clearly, we can apply the general power rule, because this expression, the square root of 3x squared minus x plus 1, when we rewrite, that is changing this radical root expression into an exponential form, it will be 3x squared minus x plus 1 to the power half. So you say, you keep the u, this as your u, the squaring function, and the n is a half. Remember, the general power rule says your n should be a rational number. That's perfect. So then we apply the general power rule. The derivative is un to the derivative of u to the power n is n times un minus 1 u prime. So wherever you see a u, you substitute this, and then you take the derivative of 3x squared minus x plus 1. Okay, so when you do n times un minus 1, so half minus 1 is a negative half. And to write it much more nicer mathematically, we can take the half times the expression of 3x squared minus x plus 1 to the negative half in this form, where we take, this expression, when you take it in the denominator, it becomes with a positive half. But to show much more mathematically, you can write it as a square root. And then times the derivative of 3x squared minus x plus 1, which is 6x minus 1. So notice how easy our life is when we apply the general power rule. Now, let's also pick up another expression which we saw in the decomposition of those composite functions. And if you remember, we had a question which says y equals 1 over x plus 1. We'd like to find the derivative of this. So the first thing we're going to do is write it in the form which makes it more easy for the general power rule. Now you can also do this expression of the derivative by the quotient rule. Now quotient rule, if you remember that formula, if not, it's much more easy to just now practice your new learning skills of chain rules. So this expression can be also written as x plus 1 to the power minus 1. And this clearly is going to be a chain rule problem here. So your u is now x plus 1, n is minus 1. So by general power rule, it's going to be n, the derivative of this y is n times u n minus to the power n minus 1 times u prime. Now n is minus 1, then u is x plus 1 to the power n minus 1. So it is minus 1 makes it negative 2 times the differential of x plus 1. Now clearly differential of x plus 1 is what? A 1. And the first expression, I can take the negative 2 and make it a positive exponent. So that means it will be minus 1 over x plus 1 the whole square. And just clean it up. So your final answer for y equals 1 over x plus 1, the derivative of that is negative 1 over x plus 1 the whole square. Well, let's work on some trigonometric functions. Again, this is a problem which has been taken earlier. So remember this one when we talked of the composition of composition functions. So I had an expression here, number 3 problem over there, that was slide 7, y equals sine square x. And I also said that this is simply sine x multiplied twice, and we can write it in the form of this, sine x to the square. So clearly it is a right function to apply the general power rule. U is sine x and n is 2. So y prime is what? N times u n minus 1 times u prime. So n is 2, u is sine x to the power n minus 1 is, that is 2 minus 1 is 1, times the differential of sine. And what is the differential of sine? It's a cosine. And the final answer for your y prime is 2 times sine x cosine x. Okay, so we have done a lot of these practice problems. Now it is your time to practice. So I have given you a very similar kind of problems to which you can apply the chain rule. And notice most of these problems you can apply the general power rule. Okay, so I'll let you guys practice on it. And in the next video, I will continue with different kind of chain rule problems. Thank you.